Good morning, everyone. Today we will continue our lesson of geometry, which is similarity. Now, let me start by giving you some important remarks. Here we have the two right-angled triangles are similar if the measure of an acute angle in one of them is equal to the measure of an acute angle in the other one. So if I have two right-angled triangles, therefore I have a right angle and a right angle. And if the measure of one of the other two angles equal the measure of this angle in the other triangle, therefore the two triangles are similar because all the measure of all angles will be the same. Here another important remark, the two equilateral triangles are similar. Two equilateral triangles, equilateral means we have three sides equal in length. Therefore, the equilateral triangle have three equal angles, which is equal 60 degrees. So, two equilateral triangle, whatever the length of their side is, they are similar. And another point, which is if you have two isosceles triangles and one of its angle equal in measure to the other angle in the other triangle, therefore these two triangles are similar. So these are very important notes. It will help you in solving the problems. Now let's go to our Carly number 2. In any right angle triangle, let me show you the right angle triangle. This is our right angle triangle. In any right angle triangle, the altitude means the perpendicular to the base, is to the hypotenuse here, because in front of the right angle there is the hypotenuse. So the altitude from the right angle to the hypotenuse separates our right angle into two triangles. Yes, these are two triangles, ABD and ADC. Now these two triangles are similar to each other and they are similar to the original triangle. Therefore, I'm going to have three similar triangles here, which is DBA similar to DAC, similar to the main triangle or the original one, which is ABC. Actually, this is the Euclidean theorem, and this is the typical shape of the Euclidean theorem, and through which we can prove, through this currently we can prove all the points in the Euclidean theorem. Okay, let's move to another point. Now we have the first theorem in this session, and it is SSS similarity. Do you remember when we said if we have two triangles and we want to prove that they are congruent? This is where we have studied this before in our preparatory stage, and we have four cases for proving that the two triangles are congruent. The first case was SSS, which is side equal side equal side. And here we are going to prove similarity, not congruency. So if the side lengths of two triangles are in proportion, not are equal like before, here we are in proportion, then the two triangles are similar. So now we need to prove, in this example, we need to prove that the two triangles ABC and XBY are similar. So whenever you have a similarity problem and you have a side length like here, so we are going to try to prove that our two triangles are proportional concerning their side lengths. So let's start. I want to prove that AB over XB equal BC over BY or equal AC over XY. So I'm going to start finding the ratio between them. So I'm going to start by AB over XB, which is equal to, now let's go to the drawing, AB and XB. AB is 12 and XB is 9. So 12 to 9 is 4 to 3. Now let's go to the second ratio, which is BC over BY. BC equals 18 plus 6. 18 plus 6 over BY. What about BY? It's only 18. So now the ratio also is 4 to 3. What about the third one, which is AC over XY? Let's check it. AC is 18 over XY, which is 13.5, and by using the calculator we are going to have the same ratio. So since we have all the sides of the two triangles are in proportion, therefore these two triangles are similar. And this is how to use the SSS theorem in proving that two triangles are in similarity case. Now let's go to another point, and in this point we have SAS similarity theorem. Now in this case it is said to be if an angle of one triangle congruent to an angle of another triangle and the lengths of the side including them are in proportion, then the two triangles are similar. Let me explain it more. I have a triangle and another one. If the measure of one of these angles equals the measure of one of these angles, and the side containing this angle and this side which containing this angle are proportional, so this side over this side equal this side over this side, then these two triangles are similar. So let's go and start solving this example, which said that prove that the triangle BDE is similar to the triangle BCA. Now, first, let me try to find the measure of one angle which is equal to the measure of another angle in the second triangle. Let me check. I have here BDE, and here I have BAC. As we can see, the letter B is common in the two triangles. Therefore, these two angles are the same. So let me find it in the first triangle, and here it is going to be angle ABC. So measure angle ABC. Now, these two angles are congruent. So, I'm not going to write it. These two angles are congruent. This angle is common in the first triangle and in the second triangle. Okay, let's start by finding the proportion of the sides. BD, let's find BD over BA, and now we need to find measured angle B and measured angle B, so we need to find the two sides that contain the angle, which is AB and EB, and the two other sides are BD and BC. So now we need to prove that EB over BC equal to BD over B. Now, let's start by BD. BD equal 4 centimeters. And what about BA? BA is this side. So it is equal 6 plus 2. 6 plus 2 equal 8. Now, the first ratio, which is BD over BA, is 4 over 8, which is half. Let's go to the second ratio, which is EB over BC. Now, EB is 6 centimeters over BC, which is 8 plus 4. So it is 6 over 12, and again we end up with half. So I have an angle congruent to another angle in the two triangles, and I have the two sides that contain these angles are in proportional. Why? Because they have a fixed ratio here. It is constant ratio, so they are in proportion. Therefore, the two triangles are similar to each other. And now, this is the end of our session. Thank you and good luck.